In part 3, we saw how transparent rendering works in ShaderGraph, and in this part, we will be exploring the depth buffer. In the previous part of this series, I mentioned that we can skip over rendering parts of objects if we know something was already rendered in front of it. But how does the rendering pipeline know anything about the relative order of objects? Colors get rendered to the frame buffer. It's essentially an image with the same dimensions as your screen, and a shader's job is to fill this buffer with color values. With this information alone, it's impossible to tell if we're about to draw over a pixel when we're not meant to. That's why we use a secondary buffer called the depth buffer. It's sometimes also called the Z buffer. This is a second image which is the same size as the frame buffer, except it stores the distance between a pixel on an object and the camera. Well, it doesn't store this distance exactly, but this is a bit complicated. The depth buffer stores values between 0 and 1 in a nonlinear relationship which prioritizes more bits for closer objects for higher precision close to the camera. All we need to know right now is that when we render something, we calculate the depth value of what we're drawing and compare it with the depth buffer value. This is called depth testing. If the thing we're drawing has a lower or equal depth value, we draw our new object over the existing one. Then, if the thing we are drawing is opaque, we also overwrite the existing depth value. Transparent objects typically don't write depth values. All of this comparison happens automatically partway through rendering the object. We don't need to write anything or add any nodes to make it happen. Now, let's explore depth in more depth. I'm going to copy the color example shader from part 1 and name the new one depth example. Don't worry if you never watched that part, the graph is very basic and looks like this. We are interested in the graph settings window, in particular the depth right and depth test options. Depth right lets you decide whether this object will overwrite depth buffer values if the depth test was successful. The default setting is auto, which does write for opaque objects and does not for transparent objects. You can choose to force the setting to be enabled or disabled, but I'd mostly just keep it as auto. Depth test is more interesting. It lets you pick which kind of comparison is made when attempting to write new pixels. The default is L equal, short for less or equal, which is the behavior I described. The test passes if the new object is closer or equal to the last drawn object at the same position. However, we can change it in many ways. Always means the new object is drawn regardless of the depth of any existing objects. Never will fail every time. Greater will only draw the object if there is an object in front of it, and so on. You can create all sorts of strange materials using these settings, and I'd encourage you to play around with different settings to see how they interact with regular objects which use L equal depth testing. The Allow Material Override button is especially useful here, because enabling this option means you will be able to modify these depth settings, and some of the other settings, on a per material basis, rather than on only a per shader basis if we leave it unticked. Remember to hit Save Asset as usual when you are done tweaking settings. So far, it doesn't really feel like we've done much shadery work, so let's explore other ways of working with depth. Our shaders can't read the depth buffer directly. Instead, after all opaque objects have been drawn, Unity copies the state of the whole depth buffer into what's called the camera depth texture, or just depth texture for short. This texture is accessible to our shaders. However, we should keep two things in mind. First, the texture only contains useful information if we're writing a transparent shader, and second, the texture will not contain any information about the depth of transparent objects. To use this texture in URP, we will first need to enable it. This is another of those things I really want to drill into your brain because you will forget this step in future projects. First, find the URP asset your project is using. if you created the project using the URP template, then this asset is in Assets/Settings. In fact, there will be 3 of them, and you should follow these steps for all 3. Select each one and tick the Depth Texture setting right at the top of the inspector window. Now that we have everything set up, let's make a silhouette shader, which I'll make from scratch via Create, Shader Graph, URP, Unlit Shader Graph, and I'll name it Silhouette Example. First things first, go to the graph settings and change the surface to transparent. Then I'll add 2 new color properties, one called foreground color and the other called background color, just to make sure their default values are distinct. Next, add a node called Scene Depth. By default, this node samples the depth texture using the screen coordinate of the current pixel being rendered, so we don't need to worry about inputting anything to the node. It has a little drop-down menu with 3 options. The Raw option grabs the depth value and does no changes to it. This is the weird non-linear value I talked about previously, and it is between 0 and 1. The Linear O1 option linearizes the depth value, and it is also between 0 and 1. Being linear in this context means an object that is twice as far away will have twice the depth value, which doesn't happen in RAW mode. The I option converts depth values to distances in world space units, basically meters, from the camera. It's useful for some effects. For a silhouette effect, Linear O1 is actually perfect. Next, I'm going to add a lerp node to my graph. Lerp is short for linear interpolation, which is a fancy term which just means I'm going to blend or mix between 2 values. The A and B inputs are the 2 values getting mixed, and the T input is how far along between A and B we are on a straight line. T should be between 0 and 1, so when T is 0.25, it means we mix 75% of A and 25% of B. As you might have guessed, we can plug the scene depth output into the T slot, then plug the foreground and background colors into the A and B slots respectively. Finally, we can slot the lerp output into the base color output block, hit Save Asset, and come back to the same view. I'm going to place a sphere with my silhouette material in front of a few objects and see what it looks like in the game view. Here, I can't really discern some of the scene objects, and that's because the far clip plane of the camera is 1000 by default. So the 0 to 1 depth range is stretched over 1000 world space units. If we reduce this value massively to something like 20, we should see the difference more clearly. In the next part, we will cover the vertex shader stage and create some effects that operate on the vertices of an object rather than the color of its pixels. Hit the subscribe button if you want to know when more parts come out. Thanks so much to my Patreon supporters who are on screen right now. Your support means a lot. You can sign up today with perks like early access and free copies of my premium shader packs. Until next time, have a great time making shaders.